Hi, we are from Group 2 from EDAV course, and in this video, we'll talk about the tidy models package in R that we can use to construct a robust end-to-end machine learning model easily. We'll illustrate how to use this package through the breast cancer dataset, and we try to classify the tumors as benign or malignant based on the cell features. And these are all the basic setup before the main tasks, such as installing the package, to look at the data structure, and also to do some basic data mutation and renaming for clarity. We'll skip the sections and go to the part one. Well, it's always important to do some data visualization before setting up the model. And we give six kinds of graphs for different purposes, such as the density plot and the box plot. They can give a sense of the distribution of the data sets. And for the feature correlation matrix, you can give us a hint about whether the features are multi-collinear correlated. All right. Um, and yeah, these two kinds of graphs are served for the similar purpose in a different manner. While for the distribution of the cost variable, it's a little bit imbalanced, but for the potential risk, we just mentioned about collinearity, and the imbalance can be solved through specific functions in the tidy models package. Yeah, so now we start building the model officially. And the first step is about the shrink test split. And we follow the convention about the 80 to 20 split of the training test. Um, yeah, and there are also some like functions like training and testing for us to have access to the data set.
After splitting the data into training and test sets, we use the recipe package to do the data preprocessing, which is really similar to ggplot in structure. Each data transformation in recipes is called a step, which starts with the step prefix. Here we use step core, step normalize, and step CV to do the data preprocessing. Another useful feature is that each step can be applied to specific variables using the outcomes or out predictors. Here we use all predictors inside each step function to only use predictor variables. After doing the data preprocessing, we build the logistic regression model by defining the model using logistic reg function and setting the engine use set engine. Next, we create the workflow to combine our logistic regression model and the data preprocessing step we define in the recipe by using the add model and add recipe function. After that, we use the cross-validation to evaluate our model by using the fit resamples, since it can apply the workflow to each of the folds we created. Inside the fit resamples, we specify which workflow we are using, which method of resamples, which matrix evaluation we are using. After that, we collected all the predictions from all folds and calculate evaluation matrix. We built the confusion matrix model by using the conf_mat function inside the tidy models. After finishing training the model on the training set, we move to the testing side by using similar method we applied before, but this time using the testing data. We similarly use calculate the confusion matrix and plot the ROC and AUC curve.
Yeah, and we also give some other models commonly used for classification tasks. But now we only need to use the update model to to set up the model and update it into the workflow, and then everything else follows smoothly. So, which is super convenient. And yeah, these are basically similar as above. So we can just skip and go to the next part. Uh, we show the results through some evaluation metrics and a visualization plot. Yeah, and it seems like all models have a good performance. Yeah, so in summary, we think Python models is very user-friendly for beginners to use. And our intro video is a hint. So if you are interested, you can feel free to explore the features and the functions in the package. Yeah, thank you.